Hello, welcome to this session on the mean and variance of a geometric distribution. Well, we're going to look at a nice example. Think about three people playing a bit of basketball. You've got Martin, Rich and Liam. They're shooting hoops on the basketball court. Now, on each throw, Martin's probability of success is 1/3. What is the expected number of throws Martin has before a success and the standard deviation? Well, we're talking about the number of trials before a success. We're thinking about a geometric probability. The expected number in a geometric probability is, nicely, it's the reciprocal of the probability itself. So, let's say X is the number of throws. We've got the formula here. Expected value of X, or mu, the mean, is 1/p. So the expected value of X in this case is 1/1/3, which is 3 throws, which makes sense. You'd expect Martin to score every third throw, so you're waiting 3 throws on average for a success. It's mathematical and it's intuitive as well. Now, what about the standard deviation? Well, we need to work out the variance first. We've got this nice formula here to do that. Variance is a measure of spread. So we've got the variance of X is going to be 1 minus P. So 1 minus 1/3 over 1/3 all squared. So 2/3 over 1/9. Well, that's 2/3 times 9/1, 3, 6. So the variance of X is 6, I believe. Now that would make the standard deviation of X equal to √6. So that's what we want. So there's your answer there for the standard deviation. And there's your answer to your expected amount. Remember, the standard deviation is the square root of the variance. Let's flip this on the head of it. We've got Rich. Now, Rich has an expected number of throws of 3.5. Well, we know we can't really wait 3.5 throws, but that's just an average, isn't it? It's an expected amount over the long term. So we're saying every 3.5 throws, he gets a basket. So, we know the expected amount is 1/p. Well, let's call Rich's weight Y. That's the variable for the number of times we need to wait. So we've got Y. Now the expected amount is 1/p. So P is 1/the expected amount. So P is 1/3.5, which is 2/7. Or the probability of Y, sorry. Should be a bit more specific there. 2/7. So 1/3.5, 2 in 7. It's intuitive. Let's see if we can work out the standard deviation. So first work out the variance of Y. So it's going to be 1 minus the probability, 1 minus 2/7, all over 2/7 squared. So that's 5/7 over 4/49. So we've got 5/7 times 49/4. So we've got, 35/4, I think. Yeah, 49/7 is 7. 7 times 5 is 35. So I've got 35/4. So that would give me a standard deviation. Standard deviation of Y would be the square root of 35/4, or square root of 35/2. And just leave it like that. I'm going to leave it in the absolutely accurate form. So my solutions there are my probability, 2/7, and √35/2. So let's think about that. 35 over 4. That's 12.75. Not 12.75. 35 over 4 is, sorry, 8.75. So we're talking nearly 3. This is nearly 3. Okay. Now C. Now, the number of throws Liam needs to make a basket has a variance of 2. Find the probability and the expected amount. So we've got another task here. We're going to use our variance. So we're going to look at the variance of Z. Liam's geometric distribution is Z. That equals 2. So we know the variance of Z is going to be 1 minus P over P squared. So let's have a look. So we've got 2 equals 1 minus P over P squared. So we've got an equation. So 2P squared equals 1 minus P. 2P squared plus P minus 1 equals 0. There you go. So try and solve this. I think we can probably factorise this. Hopefully. Should do. So we've got 1 minus 1. So that's going to be plus 1 minus 1, yes. So we've got P equals a half. So one possibility is the probability is a half and the other probability is minus 1. That's right, yes, you're shouting into the screen. That's not possible. No, not allowed. So the probability of Z is, in fact, a half. And the expected value of Z is going to be 1 over 1 over 2, which is 2. So you'd expect Liam to score every 2 throws. You'd be waiting 2 throws for a success. So, there you go. We've had a look at the spread, the standard deviation, the variance. We've had a look at working out the probability from the standard deviation, the expectation. If we just look at the formula, I mean, what you can probably quickly see is the higher the probability, the better the chance, the smaller the expected amount, you're waiting less. If you've got more chance of success, you're going to wait less chance for a success. What's always also interesting is the variance increases. The variance will increase with lower probabilities. Okay, I hope that is clear. I hope you enjoyed it. Goodbye.